In this video, I'm going to cover how the decision managers work along with the voters. There's a lot of different combinations and permutations. I can't cover them all, nor am I going to cover doing the row level type access. That was kind of covered a little bit in another video. So without further ado, we're going to talk about the standard secure access interceptor filter. Real quick, there are three required objects for an interceptor filter. You need a secure metadata source, an authentication provider, and the authorization access decision manager. Most of the time we're going to spend on this decision manager and the voters. But real quick, the authentication provider manager, this references an object that has a list of beans that can handle the different types of authentication mechanisms. So if we went and looked at this bean definition, you'd see that we have XML authentication, database authentication, single sign-on authentication. You can do JNDI authentication. There's some others, but that's what the authentication provider manager provides for Spring Security. But again, I'm going to focus mainly on this authorization access decision manager, how the URLs get protected with certain roles or authorities, and how the voters work and how you control those voters. So let's go look at this definition here. I'm going to scroll up to where this thing is defined. And we'll just kind of walk through things here real quick. So this decision manager, it has two voters, and we will cover the vote type and this allow if abstains in just a minute. But I just want to show you real quick these two voters that this manager uses. There's an authentication voter, and if we look at its definition, it's defined up here. You'll see it uses the standard Spring Security authenticated voter. And this authenticated voter, what it does is it looks at the metadata source that was provided to it via the interceptor filter, and it reads those values, and it's looking for a URL pattern, and then a predefined value like is authenticated fully, like I have highlighted here. So if I go down to my metadata source, here's my metadata source that's used. And if I scroll down through here, you'll see here that I have a number of values in here. I have the URL that's to be protected, as well as some kind of a value. And it's looking for something that is called is authenticated fully. Now typically I have this uncommented out and it actually functions, but for an example that I'm going to show in just a minute, I commented this value out. So the authenticated voter would look at all these entries, and it would look for one of these few string values that it understands, and it will then vote based on this URL request if you are fully authenticated. It checks the Spring security context, gets the user information, and sees if they're fully authenticated. So the next voter, now we've kind of touched on the authentication voter that's in that list, is the authorization role voter. So let's go look and see what that's about. So I go up here to where the security authorization role voter bean is defined, and again it uses a standard Spring role voter. And this role voter has a couple of properties. One of them that is used within the IBIS environment is the role prefix. That's the only one that's specified with this bean. And I turn that role prefix off, and there's a reason for this, basically what it boils down to is if you have a role prefix, then that means all of your authorities are going to have that role prefix for this voter to pick it up. When I turn off the role prefix, it means that this role voter is going to look at every one of the definitions that's in the metadata source and then try to make a determination whether it should vote, allow, or deny, or abstain. So that is the role voter, and it uses the metadata source again. So what happens is when a request comes in and it hits this voter, it looks at the metadata source down here, which is right here, and it runs through this list of entries here, and it says, okay, is this the URL pattern that matches the request? If it is, then I'm going to check to see if the user has an authority that is a string value of query.birth. And if it does match, if this URL matches and they have this privilege, then they will vote to allow access. Okay, if not, then it goes to the next entry. And it says, does this path match? And if it doesn't, it moves to the next entry. And it says, oh, here's all requests. And again, well, not again, but as you can guess, and it's been documented, these entries need to be listed from most specific to least specific. So I have my general catch-all definition right here. And you'll notice the value that I put in here. And this is just, there's nothing magical about this. This could be my name, it could be any value. But I want to not allow anything through if it doesn't match the above definitions. And I'll show you this example. So I put in this value here, do not allow non-matching through. And what happens is the voter comes down through here, doesn't match the first two, it hits this one, it says, oh, the user doesn't have that authority, so it will vote to deny. Okay, and if you look at the definition up here of my voter, there's a couple of other things that are tricky about this because of the actual voter that is used, the decision manager, I should say, that uses the voter. So I'm going to go back up here and look at this guy. And here's my list of voters. So the authentication voter, it voted, and then this authorization voted. And then because this is an affirmative voter, what it says, what affirmative means, and it also uses this abstain. But if it's affirmative, then as long as the voters don't vote to deny, it will assume that it's going to go through. And then based on this allow if all abstain decisions is set. If it is set to true, all that has to happen are these two voters have to abstain. Okay. If either of these voters vote to deny, it doesn't matter what this abstain value is set to. If either one votes to deny, you will not be allowed through to make that request. And if they both abstain, and if this is set to true, they will be allowed. If this is set to false and they both abstain, again, you will not be allowed through. Now there are three types of voters. There's affirmative based, unanimous based, and consensus based. And these are discussed briefly in the security notes document right here. And you'll see that's where I've got that highlighted out. So as promised, I was going to show you a quick example. I logged in as my G at G account, and I have these privileges right here. And in my browser, I made a request, and I'll just log in again. I made a request for the selection, the HTTP selection, and I want to show you why this thing stopped it. So that you see that I was denied, and if I change this back, I can go back and do show you that my birth one works as well while we're here. So we go back and I'll do a birth one, and we'll show you that it actually goes through, and I'll tell you why it works. Oh, I know why this doesn't work. This is not going to work at all. Let me show you why. And the reason is because of the way those voters are configured. So all of the secure requests go through the authenticated voter, and they go through the authorization role voter. And when it goes through this list, none of them matched, and so it denied. Real quick, there's a little trick you can do when you're debugging this stuff. So in logback.xml, I turned on logging to the debug level for my affirmative-based access decision manager. And so let me show you what the log file looks like. I'm going to see if I can slide this guy over here real quick. And so here's my log file. And you'll notice here that I have my affirmative-based voter. Here's my debug message. And it is telling us that we are authenticated, and it returned 0. You can't quite see that. It returned to 0, which means it abstained. Now the next voter that happened was the roll voter, and it returned to -1, which is a deny. And the reason that it returned to -1 is because it went through that list and it didn't find anything that matched. So the user didn't have the right authorities, and so it denied it. And this right here was just a refresh of my birth one. So here's the HTTP request, and here's the birth request. So that's a little trick you can do in your logger to see what actually is going on a little bit. And again, there's another video on the logback logger, but you just want to put in any class you want and then turn the debug level on, and you'll see any message that sometimes it's helpful, sometimes it's not. But now I'm going to go back to this def to my metadata source, and I'm going to put in my normal voter for is fully authenticated. So I'm going to make that change and restart, and I'll be back in just a minute here. So there, I've uncommented it, and I will save that. I'll restart and be back in just a minute. All right, I've restarted, and I'm going to go make this request again. So I'm going to refresh, and it's going to make me log in again. So I log in, and there it goes. There it works. Now let me show you what the log looks like at this point. Here's my affirmative-based voter. And I have to scroll over just a little bit so you can see how it voted. So the authenticated part returned a 1. So because I am using a, let's scroll up here and show you again here. Because I am using an affirmative-based voter, all that has to happen by definition is one of those voters has to vote to allow. Okay, and because I got my one allow, it is allowed to go through. I didn't get any denies. So if I wanted, say for example, that I needed to have everything be 100% voted on to allow, then I would have to use the unanimous based instead of affirmative based. If I wanted something that where only half of them have to allow it through, then I would use consensus based. And again, you have to set your abstinent decisions to all true, to allow it through, or false, depending on what you need to do. So that's basically what you need to do. So in your metadata source, and you can have multiple metadata sources if you need. So if you need a certain set of metadata sources for the request, for a given request versus another request, you certainly can do that. All that needs to happen is you create a new metadata source. You set up the voters to use that metadata source by specifying the metadata source in the interceptor filter. And if you need different configurations, then you set up a different interceptor filter, and you actually then go and map those type of requests to that interceptor filter, and that is done at the top of this file and with the filter chain that's specified within the proxy, and you kind of get the idea. There's some other videos that tell you how to connect those dots, but there's lots of options on this, and it can be quite confusing. But you just kind of have to go through each little step, turn on the debug mode, read your logs, and you should be able to figure it out. Hope that was helpful, and as always, please feel free to call and ask questions.